All right, so in our lesson today, we're going to be talking about the Great Lakes and climate. We're going to talk about a microclimate in Michigan. So Michigan is kind of a somewhat special place. It has some unique things about it. We're going to talk about its microclimate. In one lesson, we'll talk about lake effect snow. In another lesson, usually we talk about things that make Michigan unique, like our awful Lions football team. I'm not hating on the Lions. I'm a fan, but they're awful. They're getting better, though. So we're going to focus on something a little more special in a good way, talking about the fruit belt. There we go. When you're done with today's lesson, you should be able to talk about microclimates in Michigan. So first of all, what is a microclimate? Or we talked about climates being kind of the long-term or average atmospheric conditions for an area. When we talk about microclimates, we're talking about a local climate that's different from the regional climate. Okay? So one of the kind of neat things about Michigan is its climate, the regional climate of the Great Lakes, is different than other areas that are at 45 degrees north. But even within Michigan, there are some smaller regions or smaller areas that have a unique climate. And not surprisingly, one of the things that helps give Michigan its unique climate, its unique microclimate, is water. So one of the principles of water is that it absorbs and releases heat easily. When there's a basin of water like the Great Lakes, the ability to hold onto and release heat can have a significant impact on the surrounding coastal areas. Those coastal areas throughout the Great Lakes are often referred to as the fruit belts. This lesson is going to be exploring kind of water's ability to absorb and release heat, the effect that the Great Lakes can have on the surrounding land, and how that relationship between those to influence the economy and culture of the Great Lakes coast areas. All right, so first we'll take a look at how the Great Lakes influence weather and climate. So we talked about how they influence the climate and the weather in kind of several ways. We're going to be taking a look at how the Great Lakes act like a heat source and how they act like a heat sink. So a heat sink is any substance that's absorbing more heat, taking in more heat than it's giving off. A heat source is a substance that is radiating more heat than it's absorbing. So again, radiating just means that it's giving off energy. So here we have our fancy diagram of science. On the left, we look at the temperature of the lake is less than the temperature of the surrounding land. Doesn't really matter what that temperature is. We just see that the temperature is lower here. So it's a heat sink, so heat would be transferred from the land to the ocean. In this scenario here on the right, the water is warmer than the land temperature, so the heat would be transferred from the lake to the land. Or actually, I'm talking about transferring from water to lake, or lake to land, or the other way around. Really what we're talking about is the air above it. All right, I'm sure, like most Michiganders, you guys have spent at least a little bit of time at the beach, whether it's one of our many local lakes or one of our big Great Lakes like Ludington. Probably have noticed that when you go to the beach, the air tends to be a little bit cooler. So you're directly experiencing how the Great Lakes can have an impact on the air temperatures. So during the summertime, the air temperatures are usually quite a bit cooler at the edge of a lake compared to even just a few hundred feet inland. Part of that is because water keeps its energy a lot longer than other substances. The reason it does that is because it has what's called a high specific heat. And specific heat is the heat that's required to raise temperature of a unit by 1 degree. So how much energy does it take to raise that unit of a substance 1 degree? And so it takes quite a bit of energy then to do that with water. We talk about water actually having a specific heat of 1, and you might think, well, okay, you said it takes quite a bit. 1 doesn't seem like a whole lot. Most other substances are less than 1. Okay, so the specific heat for water equals 1. Most of them are less than that. So water then has a greater capacity for actually storing the energy. So it absorbs the heat slowly, and then it can absorb more energy than most other substances. Other substances act as heat sources and sinks too, but they can't hold on to the heat and energy like water does. And the water also releases it into the atmosphere. Think about metals. Metals heat up very quickly, but then they also would cool down very quickly when compared to an equal amount of water. So I mentioned swimming at the Great Lakes. Anybody ever been swimming in Lake Superior? Show of hands. Yeah, more than my other group. Yeah, I've never actually been swimming. Wait, yes, I have been swimming in it. I was going to say I don't know that I've ever been swimming in it. I dipped my toes in, but yeah, I did actually go swimming once in Lake Superior, and it was in the middle of summer, and it was still darn cold. Okay. How about Lake Michigan? Probably a lot more, right? By the way, if you go to the beach at Ludington, that's Lake Michigan. I still have high schoolers who go, oh, I didn't know that. So yes, Ludington is Lake Michigan. So if you're swimming in Lake Michigan or Superior, if you're doing that in May, it's a very different experience than swimming in that lake in August. You may have a day where the temperature is actually the same. It could be a nice 75-degree day in May and a nice pleasant day of 75 degrees in August, but you're going to find that the temperatures of the water quite a bit different in May. May is going to be a lot colder. August is going to be a lot warmer. Again, that's all kind of a result of that specific heat of water. It doesn't want to change very easily. All right, so now we're going to talked about the atmosphere, climate, weather part. Now we're going to take a look at the fruit belt effect, which is something that happens as a result of that. So the Great Lakes, again, we talked about how they can be a heat source. In the wintertime, they're going to be a heat source. Coastal air temperatures are going to be more moderate than the air temperature that are farther inland. The lakes act to kind of smooth out the seasonal changes along those coastal areas. You're going to have fewer temperature extremes along the coast. These provide ideal conditions for the very profitable fruit industry. So in addition to being famous for our horrible football team, we are also quite famous for having things like cherries and apple orchards, and even have some quite a few vineyards. Okay, all of that is a result of this fruit belts and kind of these moderating effects. So early blooming fruit, the delicate early blooming fruit, typically only grown in the south, can thrive in a narrow band of land about 30 miles wide along the Great Lakes shores. The primary fruit growing areas in the Great Lakes include the east shore of Lake Michigan, as well as the southeast shore or shores of Lake Erie in Ontario. And I've got some maps and graphs here I'll show you in just a minute. On these maps here, I know they're a little bit hard to see on our slides. I would never ask you guys to memorize this kind of information, but I would expect you guys to be able to interpret a map like this. Okay. So again, I know it's a little hard to see out there in TV land, but we're kind of in this general ballpark. That's a number 10. And if we were to go up here and read our key or legend, it says farm types are primarily dairy, potatoes, and truck. So, and that kind of sums up our general area. All right, mean frost days. By mean, we're not talking about somebody's attitude, right, or temperament. We're talking mathematical mean, which is kind of, what's the mathematical mean? Average, right? So average number of frost-free days. Okay, so we can see a kind of higher number of frost-free days along that coast. If you can go into your neighborhood farmer's market, find locally grown peaches, apples, pears, plums, grapes, berries, you probably live near one of these few special areas found in Michigan. Yeah, I left out raspberries and blueberries. So those are some other kind of tasty treats we find around here. Here's how the heat sink and heat source properties of the Great Lake work throughout the year, as well as how they influence those fruit belt areas. In the winter, there's less radiation from the sun, generally making temperatures colder. That means that the lakes are warmer than the air. However, the lakes become the heat source, giving up their energy to the atmosphere throughout the winter. As air passes over the lakes, it warms up and carries that warmth for about 30 miles inland. Warmer air keeps the fruit trees and plants from being frozen and killed by below zero temperatures. In the springtime, water stays cooler longer than the air and land. Air passing over the lake cools off and stays cool around the fruit area. This cooling slows the development of fruit blossoms. The trees and plants blossom later when there's less of a chance of damage by frost. In the summertime, temperatures of the Great Lakes water tend to increase, okay, or becoming warmer during the summer. The lakes are storing up extra solar energy from the atmosphere and acting as a heat sink throughout the summer. And then we get back to late summer and early fall. The warmed water of the lake region again warms the air above it and kind of protects those mature fruit from being damaged by early frost. And again, we have some more kind of charts and graphs here showing some different patterns. Winter temperatures, ice conditions, frost-free period, and air masses. Just make sure that you're able to kind of read those and get information from a chart like that. Here's one of those, our final slide here showing the acres and orchards, kind of showing that pattern where we see a high number of acres and orchards along our west side, the east shore of Michigan, and then in these areas over here as well. All right, that's going to do it then for our lesson.